So today we are going to discuss about the concept that is drift velocity. For example, to explain this drift velocity, I'll consider a conductor. Now for example, consider this as a conductor. So consider this as a conductor. Let us consider the length of the conductor as L. And let us consider area of cross section of this conductor as A. Now let us say this as uniform conductor or conductor of uniform area of cross section. So if this area is A, here also the area is A. Now what is the volume of this conductor? Means volume of the conductor is V is equal to area into L. Now I will connect this conductor to a battery like this. So I will connect a conductor to a battery like this. Let us say this as positive terminal of the battery, let us say this as negative terminal of the battery. Now, I will consider an electron on this surface. Clear, I will consider an electron on this surface. Now, this electron will rushes towards the positive terminal of the battery. Now, whenever this electron is rushes towards the positive terminal of the battery, it may collide with the other particles present inside this conductor. Now, inside this conductor, we have number of electrons. There are number of electrons. Don't say infinite. So, there will be number of electrons. Now, this electron may collide with other particles present inside this conductor when this electron rushes towards the positive terminal of the battery. So whenever this electron is moving in this direction, it may collide with this particle, and after collision it will changes its direction and velocity. It may collide with another particle. Later it may collide with another particle. Again it may collide with another particles. Like that, it will make multiple collisions whenever it reaching from one end to another. So this electron is going to make the multiple collisions with a number of other particles whenever it is moving from one end to another. Okay. For example, at each and every collision, the velocity of the electron may changes. So whenever this electron is collision with this electron, because of the concept of elastic collision, there will be exchange of momentum. Therefore, velocity will changes. The velocity may increase or decrease, so velocity will changes. So here velocity changes at each and every collision, and direction will also changes at each and every collision. So finally, if you consider the path of this electron, the path of the electron is in random motion like this, or random like this. Clear? So it moves in a random path to reach to the other end. Clear? For example, if you consider this electron will move in a random path to reach to the final end. Clear? So I hope you understood this point. Now I am going to write a matter here. Let us consider a conductor of length L and area of cross section A. Okay, so length of the conductor is L and area of the cross section is A. Let an electron is moving towards the positive terminal of the battery. Clear? Positive terminal of the battery, that is from one end to another end. Clear? Positive terminal of the battery, that is from one end to another. Clear? So it is moving from one end to another end and finally reaches to positive end. For example, in its path, it may collide with the other electrons. Clear? It may collide with the other particles. Clear? In its path, it may collide with the other particles and it changes its motion randomly, or it moves in a random path and finally reaches to the other point. Clear? So that point I am going to write in its motion. This electron will collide with other particles will collide with other particles and changes its velocity and direction. Clear? So it changes its velocity at each and every point, not only the velocity, it will changes its direction because of the elastic collisions or because of the collisions between the two electrons. Now, if you take the velocity, let us say for the first collision I will take this velocity as v1, for this collision I will take velocity as v2, for this I will take it as v3, for this I will take it as v4, for this I will take it as v5, for this I will take it as v6, v7 and so on. If I take the average of all these velocities, then you can take like v1 plus v2 plus v3 plus and so on divided by n. That is nothing but average velocity of all these electrons. So the average velocity of an electron inside the conductor is taken as the drift velocity. Clear? Is taken as the drift velocity. Clear? Now I am going to write that point. The average velocity of an electron inside the conductor is called as drift velocity. Clear? That is called as drift velocity. Now that drift velocity is represented with letter, for example, I will take it as v suffix d, that is equal to, now remember, velocity formula is displacement by time. Now what is the displacement of this electron means? Let us say the electron moved from this right end to, let us say it moves to left end. Now what is the displacement from left hand, right hand to left hand means the displacement is L. Now what is the displacement here means displacement is L. Let us consider the time taken by the electron move from this end to this end, the time I will consider as t. Therefore, I will consider drift velocity Vd as L by T. Let us take this as equation number 1. For example, initially I will remove the battery. If I remove the battery, what is the velocity of electron means velocity of electron is taken as 0. Clear? So the velocity of electron is taken as 0. Okay. For example, initially if I remove the battery, then what is the initial velocity of electron means initial velocity of the electron is equal to 0. Now for example, if I connect the battery, clear? If I connect the battery, then this electron will be accelerated towards the positive terminal of the battery. Once again I will repeat, whenever you connect the battery, then this electron is accelerated towards the positive terminal of the battery. Right? Now why? Because here there will be change in the velocity, so change in the velocity is nothing but acceleration. So here the electron is accelerated towards whom? Positive terminal of the battery. Why? Because this electron will move towards the positive terminal of the battery. So whenever this electron is getting accelerated, it will collide with the other particles. So whenever this electron is going to accelerate, it will collide with the other particles. Now for example, I will take this as an electron, I will take this as first particle. Now first this electron will collide with this particle, then it will change its velocity, velocity may increase or decrease, and it will change its direction. Now again it is moving in this direction, in its path it may collide with another particle. Clear? If it collides with another particle, again it may change its velocity and direction. Now, the time taken between two successive collisions, for example, I will take this as a first collision, I will take this as, for example, second collision. The time taken between two successive collisions is called as relaxation time. Clear? The time is called as relaxation time. And the path covered between the two collisions, that is called as free path or mean free path. Here I am not gonna explain about this. I will take this point, that is relaxation time. Now remember, the time taken between two successive collisions. First I will take like this. For example, if the battery is off, or if the battery is in off state, then initial velocity of the electron is 0. Initial velocity of the electron is 0. I will consider that initial velocity as u, that u is equal to 0. Now, if we connect the battery, then electron is accelerated towards the positive terminal of the battery. For example, if the battery is on, then the electron is accelerated towards the positive terminal of the battery. So positive terminal of the battery. So here I told the electron is accelerated, therefore we will find acceleration. Now how to find out the acceleration here means, we know that F is equal to Q into E. Clear? So where E is electric field, Q is charge. Now E I will consider that as an external electric field, that is from positive to negative. Now what is a charge here means, here the charge is nothing but electron. For electron I will take Q value as E. Then force F is equal to Q into E. And I will write force F as mass into acceleration, that is E into E. Now acceleration I will consider as A is equal to E by M, where E is charge of electron. So where E is charge of electron, capital E is external electric field. Okay, and what about M means? M is nothing but mass of electron. I hope you understood. Now just now discussed, here an electron will collide with other electrons also. Now the time taken between two successive collisions is called as relaxation time. Now I will write that point. The time taken between two successive collisions is taken as relaxation time. That is taken as relaxation time. The relaxation time I will consider this as tau. The time I will consider as tau. Now write all these points here. For example, initial velocity u is equal to 0, and then acceleration a is equal to E, capital E by M. Now relaxation time I will take it as t is equal to tau. Now I will take final velocity. That final velocity v can be taken as v. Now we have initial velocity, final velocity, acceleration, time. Now which kinematic relation we can use means, we know that v is equal to u plus at. So use this kinematic relation. From this kinematic relation we can say this as vd is equal to 0 plus capital E small e by m into tau. Now drift velocity Vd can be taken as E by m into tau. So this is the expression for drift velocity. So this is the expression for drift velocity. So this is the expression for drift velocity. Now we can express this drift velocity in another way also. Now I am going to explain that. Yeah, please go. I'll take this as a conductor. I'll take this as a conductor. What is the length of the conductor? Means length of the conductor is taken as L. Area of this conductor is taken as E. Okay, so we already wrote the points. Now let us say there are any electrons. Let us say there are any electrons on this surface. Clear? Now let us say on this surface we have any number of electrons. Okay. So on this area we have any electrons. Are you clear? For example, let us consider, Ne is the number of electrons on the area of cross section A. So on this area of cross section we have any electrons. Now this in the entire volume, what is the number of electrons means? Clear? So the number of electrons in the entire volume or the number of charges in the entire volume. I will take the number of charges as for example Q. Now for example, the number of charges in the entire volume is so the number of charges in the entire volume I will consider like this. So Q is equal to Ne is on the charges on this face. Now in the entire volume, now what is the volume of the conductor means initially we wrote volume of the conductor V is equal to A into L. Now in the entire volume, how many charges will be there means Ne into A into L. So Ne is the charges on one face. Now on the total conductor, what is the number of charges means Ne into A into L. For example, I will take this as equation number 2. Now I will take this as equation number 3. Fine. Now we know that current I is equal to delta Q by delta T. Or you can take this as dq by dt also. Let us say this as an instantaneous current. Now you can say current I is equal to d by dt of, clear, what is a Q value means that Q can be taken as NEA into L. Okay, I hope you understood. Or else you can take like this also, no problem. So from this you can take dq is equal to I into dt. Okay, or else you can take like this also. So I is equal to d by dt of this value is NEA into L. Okay. Now listen, I will take I is equal to, this can be taken as NEA, I will take it as common, into dl by dt, into dl by dt. That dl by dt from equation number 1 you can say that as drift velocity. So L by t, if I take this as for example dl by dt, that dl by dt I will consider as drift velocity v. So where velocity v is equal to dx by dt or rate of change of displacement. Clear? So velocity is taken as what? Rate of change of displacement. Now from this you can write like this also. What is that means? Drift velocity Vd is equal to I by NEA. But we know that I by A can be taken as current density J. Therefore, drift velocity Vd can be taken as J by Ne, where I by A is nothing but J. Now this is also taken as drift velocity, equation for the drift velocity. Clear? So this is also the expression for drift velocity. Clear? So this is also the expression for drift velocity. Yeah. Now we'll go for the next concept. Now I'll go for the next concept, that is relation between J sigma E, where J is current density, sigma conductivity, which is called as reciprocal of resistivity, E electric field. So now we are going to find out the relation between J sigma E. Now we know that Ohm's law is, what is Ohm's law? So Ohm's law is V is equal to IR. Clear? I'll take this as equation number 1. For example, I'll take the resistance. So we know that resistance R is equal to rho L by A, where L is length of the conductor, A is area of cross section of the conductor. Now we know that electric field E is equal to V by D. I will take that distance as L, where L is the length of the conductor. For example, if you take this as a conductor, the distance traveled by the electron is, for example, this distance is L. So that can be taken as V by L. Or else from this you can write V is equal to E into L. Now substitute these two values in the above equation, then we have E into L is equal to I into R value rho L by A. Now cancel L and L. Then we have E is equal to, I will write I by A value as J into rho. Since I by A is equal to J. Now I bring this rho to the left hand side, then 1 by rho into E is equal to J. Now we know that 1 by rho is equal to sigma, where sigma is conductivity, reciprocal of resistivity. Now you can write this as J is equal to 1 by rho can be taken as sigma, rho is resistivity, sigma is conductivity, you can take this as sigma into E, therefore J can be taken as sigma into E. Now listen, what do you mean by J? Means J is nothing but current density, which is a vector quantity, and what is E? Means E is nothing but electric field, which is a vector quantity. Now this is similar to I is equal to, clear, V equal to IR, then I can be taken as 1 by R into V. Clear, it is similar to I is equal to 1 by R into V. So it is similar to, for example, instead of current we have current density I by A. Are you clear? So instead of electric field we have potential, that is V by L. So V by L is equal to E. Therefore this can also be called as, vector form of Coulomb's law. Ohm's law. So this is also taken as vector form of Ohm's law. Okay, I hope you understood. So here J bar is a vector, then E bar is a vector. Clear? Now I'll go for the next concept. Yeah. Now I'm going to the next concept, that is calculation of resistivity. Or else I'll read this concept as relation between rho, tau, sigma and E. Clear? So relation between rho, tau, sigma into P. Now I'll tell you in an easy way what are the expressions we learn. From that expressions only we are going to derive. Now remember, we know that drift velocity Vd is equal to, clear, small e capital E by m into tau. This is taken as equation number 1. But for drift velocity we have another expression Vd is equal to j by Nv. I will take this as equation number 2. Now both represents drift velocity only, therefore you can write this as j by Ne is equal to E by m into tau. Now bring this Ne to the right hand side. If you bring this to the right hand side, then j is equal to Ne square E by m into tau. Or else I'll further modify like this, that is j is equal to Ne square tau by m into E. If you compare this equation, so compare this equation with the previous concept. For example, I take this as equation number 3. Now compare this equation, clear, compare the above equation with j is equal to sigma. Therefore, in the place of sigma, what we have means in the place of sigma we have Ne square tau by m. Clear? In the place of sigma we have Ne square tau by m, where sigma is called as conductivity. Therefore, conductivity, clear? Therefore, conductivity sigma is equal to Ne square tau by m. Now, from this we can say that sigma is directly proportional to the relaxation time tau. So, I'll explain about this concept later. So here conductivity sigma is equal to Ne square tau by m, then sigma is directly proportional to tau, where tau is nothing but relaxation time. Now we know that rho is equal to 1 by sigma. Therefore we can say that rho is equal to 1 by sigma, that is 1 by Ne square tau divided by m. Now this m will go to the numerator, then rho is equal to m by Ne square tau. Now from this equation we can say that rho is inversely proportional to the relaxation time. Clear? Rho is inversely proportional to the relaxation time. Therefore, if relaxation time increases, then resistivity decreases. If relaxation time increases, then conductivity also increases. Now if relaxation time decreases, then resistivity increases. If relaxation time decreases, then conductivity increases. So in the next class, we are going to use these equations and will explain how a resistance, or for a conductor we are getting resistance. So how we are getting resistance for a conductor? So based on this concept, in the next class we are going to discuss. Thank you.